So in this video I'm going to discuss Codeforces around 950 rated for division 3. So I will be solving first 5 problems of this problem set. So let's start with problem A, that is problem generator. So in this question we are given a string A, okay, and we have to tell whether it is possible to construct a string which contains A, B, C, D, E, F, G total number of m times, whether it is possible or not. If it is possible, then answer is 0. If answer is not possible, then tell how many number of characters you have to append in the string so that the answer is possible. So I think so the solution is very much simple. You just have to make the frequency of each and every character in this initial string and check whether you can make character from A to G total number of m times. If any of the number is missing, just increase the count for that number because you want to add that number in the string. So the answer is pretty much simple. I hope so you can do it. So let's go to problem B, that is choosing cube. So in this question we are given total number of n cubes, number from left to right from 1 to n. Okay, and a cube with index is his favorite. Means there may be a character and his his favorite number is at index f. Okay, so for example this is a test case. This is the initial array and we are given a f is equal to 2, which means the number at index 2 is his favorite, that is 3, that is number 3. Now what he said, you have to sort the array in the decreasing order. Okay, I have sorted the array in decreasing order. Now remove the first k characters, remove the first k elements from the array and tell whether his favorite number is there in the array or not. So the answer is this answer is very much also simple. Let me try to make this answer bit clear here to you. So what is the array? 4 3 3 2, what is 3? So okay, again 3. So if we sort the array, then it will be 3 3 3 and 2. So now if I tell you that you have to remove first two characters from the array, okay, now you can see that at the kth character the value is his favorite number, and after the kth character the value is also his favorite number, which means the answer is yes. Okay, in this case the answer is will be yes. So let me take another case. Let me 4 3 2 1 0. So in this case let k is equal to 3 and your favorite number is 0. Okay, now you will check if the number at the kth position, that is 2, if the number at the kth position is greater than your favorite number, then answer is yes, which means if this number is greater, then definitely it is beyond this scope, which means it will never be cut out. The answer will be yes. And similarly for the another test case, let me take this only 3 1 0. If your k is equal to 1, which means you will check and your favorite number is 3. Okay, you will check if your kth number is greater, or if your kth number is smaller than your favorite number. If it is smaller than your favorite number, then answer is no. Which means it will be cut out from the from by removing the first k element of the array. So the logic is very much simple behind this intuition. I hope so you can guess it. So let's now discuss the problem number C, that is Sofia and the loss operation. Okay, so this question was also very much easy, I would say. But why? So you are given two arrays. Let me discuss the test case only. Okay, let me discuss this test case. So you are given two arrays, array number A and array number B, and you have constructed array A, array B from array A. Now you are given some number of points D. Okay, what are these points? Okay, let me tell you the question from here only. So you are given some number of operation which is of pair type, that is A1 A2. In this case it is Ci and Dj, which means you will replace the index at Cj with value Dj. Okay, let me repeat it again. For example, it is here. This is array A. So for example, a query is of type 1 comma 2, which means you will replace the first index with 2, which means now it will become 6 2 6 1 10 and 10. Okay, now this will be your new array after this operation. Now you have to tell them whether array B is possible to generate from an array A if this is the given possible values of D's. Okay, these are only D's. What is a pair? Ci and Di. Okay, this is only D's, which means you have to tell whether a corresponding pair of Ci is also possible with this Di, such that you will get array B from array A. So how to solve this problem? First of all, you will check all the differences. Let me tell you here, like it is 7 6 1 10 and this is 10. Now this is will be 3 this will be 6, this will be 1, this will be 11, and this will be 11. Now you will check all the differences, which means at what pair they are differentiating. So you know that 7 is different from 3. Now you will check whether 3 is there in your string, in your D's. Yes, it is there because it should be there. If it is not there, then how you can convert AI to this value to this value, which means this value should be in your DIs. Okay, let me mark this, let me make it cut. Okay, now this is equal, this is equal. Now is there 11 in your array? Yes, 11 is there. Now okay, cut. So is there any one more 11 in the array? No, there is no one more 11 in the array. So answer is no. Okay, so this is how you can solve this problem. But no, this is not it. So let me now discuss another test case. So that would be, I guess, yes, this is also pretty much good. So let me get back to it later. Okay, let me see if it can be valid or not. Okay, so just take a random test case only. It would help more. Okay, so now discuss this test case. So first of all, find the differences at where it is not differentiating. So my 3 is equal to 2. No. So is there 2 in the array? Yes, 2 is in the array. So first of all, let me, you have to also take care of a index, which is the last. So you will perform the operation in this manner only. Okay, this is the condition of the array. So you will always try to mark your index at the last, which means if this 3 is converted into 2, then you will check whether 2 is there in the array or not. If 2 is there in the array, just store that index. That is, what is this index? 1, 2, 3, 4. That is 4. Index is equal to 4. Now cut it. Now 1 is equal to 2. Is 2 there? Yes, 2 is there. Cut it. 7, 7. 8 is equal to 10. 10 is there? Yes, 10 is there. Now you will notice one thing. That your 3 is left. So for this case, let's suppose 1 is not there. Okay. So for, let's suppose you see that 3 is here. Now tell me whether how you can handle this 3. You can simply handle this 3 easily because you can make a bluff. For example, your 1 should be converted into 2. Yes. So make a random test case like 2 comma 3, which means 2 index convert to 3. Then make another case is 2 comma 1. Is this one and only the same thing? Yes. Because first of all, you're converting 1 to 3. Now you're converting 3 to 2, and at then you are making it 2 only, and you're moving in this order only. So that is how you can solve this problem. So let me take another test case. So I hope so it is clear to you. Just mark the last index possible. So if there can be example of not a last test case, I can say yes, 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 there's a test case. Let me repeat. For example, there's a 2 after it also. Okay, there's a 2 after it also. Now you mark this 2 as the last index. Okay, if you mark this 2 as the last index, then you know how you can perform operation using this 2, because you have to perform the operation and you're left with 0 indexes. Yes, so that's why I'm telling you, just mark the last index possible. So for this test case, you will mark this as a cut, which means your index would be now 5. Now you can easily know how you can handle the test case of 2. Just make a bluff with any of the existing test case and you will achieve that answer. So there's a very good test case for this. Like, you're given an initial array. Let me erase this part. Let you are given an initial array A and you are given a final array B. This is A and this is B. And the number of operation you are given with is like 1, 2, 3, 4, 5, and suppose 1 also here and 1 also here, that is 6 and 1. So these many number of operation you are available with, and tell how you can perform the operation. So first of all, if you select this to this, if you want to convert this to this, you select this move. Okay, you select this move. Okay, done. So now you're done. What happened to these moves? Are you able to make, are you able to consume all the steps? No, you are not able to consume all the steps. So if you greedily take this one, okay, if you greedily try to make this one, because for, let me repeat it again. So tell me what index you will be your final index at which you are making this one is equal to 1. If you are selecting this index, then what will happen to these indexes? This will all be remained and your answer will be never be achieved. Okay, so if I tell you, just for the last operation, choose this index, choose this number. Okay, I'm choosing this number, which means we can perform all this operation on this index only, and at then finally choose this operation and make it equal. Okay, so I hope so the problem statement is clear to you. So example, this is 2, this is 1, this is 2, and operation you are available with is 3, 2, 6, 1, 7, and again 2, and then again 6. So in this operation, you have to convert 1 to 2. So what operation you will select? You will select this two. Okay, done. But you know one thing, 6 is left. 6 is left. Your maximum index in this array is now, what is index? 1, 2, 3, 4, 5, 6. That is 6. So in this test case you cannot never make this a is equal to b, because you will always be left with one operation and you cannot consume that operation. So suppose you are having a 2 after it also, then can you make it? Yes, you can definitely make it. Then just consume this index at the end and make index is equal to that is, but will that is equal to 8, and your answer is yes. So the implementation is very much easy also. Let me show that part also. That is a, b and c. First of all, make the occurrences of all the letters in your D array and find the index of that array also. Okay, if your current number is not equal to your b, if your a of I is not equal to b of I, then just find whether your D array contain that number or not. If it does not contain, then answer is simply no. If it contains that number, then simply decrease the frequency, and if its frequency becomes 0, then erase it from the map and store the maximum index of that number. Okay, if your both the numbers are same, if your both the numbers are same, then also you can store the maximum index, because that is also a helpful operation. So let me take this 1 comma 1 test case. You know, these are both equal, these are both equal, then you can simply return no, because both of them are equal, and you will choose none of the operation. But you have to make all of the operation. This is the test case, this is the question. You have to consume all of the, you have to consume all of the operation. So if your both the numbers are equal, and that number is present in your b array, then you can store that maximum index, because you can see here what I have done. My 1 is equal to 1, and I have stored the maximum index of that one also. Okay, if my 1 is equal to 1, but if my 1 is equal to 1, then store the maximum index in the array. If your maximum index is equal to last index, then answer is not equal to last index, then answer is no. Because what is your main goal? Your main goal is only that you can consume all of the operation, which means that the operation at the last index, the operation that is a last index should be consumed somehow. Okay, if it is consumed somehow, then answer is yes. If it is not consumed somehow, then answer is no, and simply return. So that's how you can solve the problem number C. So let's now discuss problem number D, that is GCD sequence. So this question is very much interesting. So in this question, you are given an initial array A, and you have to construct you have to construct an array B, and you have B of I is equal to GCD of A of I comma A of I plus 1. So you have to tell whether it is possible to exactly remove one element from your array such that GCD of sequence B is non-decreasing, i.e. it means it is always increasing. So for example, this is the array 26, 12, 3, 40, 36. Now if she removes A of 4, that is this value, then if you find the B array, that is GCD of the adjacent numbers, then GCD of 20, 6 is 2, GCD of 6, 12 is 6, GCD of 14, 12, 48 is 12, and similarly this is also 12. Now it is increasing. Now you know one thing, that by removing 3, you are able to make GCD in increasing order. But how to solve this problem? So the answer is very much simple. But why? Let me tell you why. So for example, this is the existing. So let me debug this only. So I will tell you the answer from this test case only. Okay. So first of all, find the GCD array. But original GCD array. What is a GCD of 20, 6? I think so. It is 2 only. Yes, 2. GCD of 6, 12. That is 6. GCD of 12, 3. That is 3. GCD of 3, 48. That is again 3. GCD of 48, 36. That is 12. So now it is somehow increasing, then decreasing. Okay, somehow increasing, then decreasing, and then again increasing. Okay, so this is the final output array, which means at what point anomaly is being created. Okay, let me repeat again. At what point in an array A, thus it is making your array not good, you're making it non-decreasing, increasing. So what is the that point? I think so that point is only, what is that point? That is 6, this one and this one, which means these two are the indexes, these two are that indexes in which your array is becoming not equivalent, in which you're not getting a good result. Okay, so let me try to remove from this part only. This is the whole intuition. first of all First of all, try to remove this number, then try to remove this number, then try to remove this number. If by removing any of these three numbers you are able to make final GCD as increasing, then your answer is yes, else your answer is no. So pretty much simple, right? But why it is so simple? So let me tell you again. So this is the only adjacent pair which is making your which is not making your array be good. Okay, so this is the only index which is making your array be not good. Yes, this is the only case. But so first, no, now you know one thing, that your this number is not depending on any of the number. Now tell me whether your this 3 which is now decreasing is depend, let me change the color, whether this 3 is dependent on any of these numbers or any of these numbers. The answer is no, which means your 3 is not dependent on any of the previous number or any of the next numbers. The previous means and means these numbers and these numbers. Your this 3 does not depends on any of the these numbers and these numbers. So you will make a change in this pair only now. Okay, first of all try to remove this, then try to remove this, then try to remove this. If by removing any of these three numbers, if your final array is just increasing, then answer is no, the answer is yes, else answer is no. So pretty much simple. If you show the code is also easy. So this is the, okay, so this is the code. So first of all what you will do, you will first of all find the GCD of your whole array. Okay, the array number b. if your if your array b is if your array b is already good, if your array b is already good, then simply print yes, else print no. Okay, first of all find that index at which point your anomaly is being created, which means what is that point? That point is 6. Okay, your 6 is greater than 3, which means it is now array is now decreasing at this point, which means I do not like this. So let me recreate it, which means your array is first of all increasing then decreasing at this point. So I will mark this point as index. Okay, mark this point as index. Okay, if your none of the index is present, which means your array is already increasing, then answer is yes, print is simply print yes and return. Okay, now what I will do, I will simply create three arrays and try to remove these three numbers. One number would be 12, one would be 3, one would be 48, or I can say 6, 12 and 3. Try to remove these three numbers. If you're removing any of these three numbers, you're getting a good array b, then answer is yes, else answer is no. You know, now notice one thing, I'm first of all what I'm doing, if my index is not equal to index plus 1, so by except the index I plus 1, I'm putting all of my numbers in array a. Okay, except the index I plus 2, I'm putting all my numbers in array 2, except the number index, I'm moving all my numbers in array 3. Okay, now generating the corresponding array b also for each and every array 3, array 2 and array 1. Now if any of these three array satisfy the condition, then answer is yes and answer is no. If any of these three array satisfy the condition, then answer is yes, then answer is yes, else answer is no. So pretty much simple, right? Yes, that's the whole d problem. So let's now discuss the problem very, that is permutation of rows and columns. So I like this problem very much. So I think so this is not a problem of level C, I would say. So here you can see it is almost touching 4000 and it is a E problem. So what is the problem? So you are given a matrix. Okay, you are given a matrix, and your matrix contain a permutation of n numbers, which means, let me repeat again. So for example, if you're given a matrix of n rows and n columns, which means the only numbers in the matrix would be till from 1 to n into m. Okay, from 1 to n into m. Okay, all of your numbers will be between 1 to n comma n, which means your if you sort all the numbers of your matrix, then it would make a sequence from 1 to n into m. That is the pretty much definition. So you are given an array a, and you are given a matrix a, you are given a matrix b. You have to tell whether you can construct array b from array a, and what is the operation allowed. Operation allowed is that you can swap any of the two columns, or you can swap any of the two rows. So the answer is very much easy. So first of all, try to think yourself only about this problem, because this is a very much easy. I'm repeating, this is very much easy. Okay, okay, done. So what is your array? So one of your array is 1, 5, 9, 6. Okay, that is 12, that is 10, that is 4, and that is 8. Okay, that is 7, 11, 3, 2. And what is your next array? That is 1, 5, 9, 6, that is 12, 10, and 4 and 8. Okay, that is 7, 11, 3 and 2. Okay, now these are your both of the arrays. Now you have to tell them whether you can construct this from this. I think so these are both equal. What the f, 1 2 3 4, 1 2 3 4. Okay, I've taken the both of the same arrays. Okay, so let me try to take another test case. That is, hope so they are not equal. Yes, they are not equal. Good, good, good. So okay, so let me try now to make this array. That is 1 5 9, and that is 6 4 2, and that is 3, that is 8, and that is 7. Okay, now what is 5 9 5 1, that is 2 4 6, and this is 7 8 3. Now you can make from array this to this by specifying any of the rows or any of the columns. If yes, then print yes, else no, print no. So pretty much simple, right? But is it? So let me try to find out. So what you are given in this question, so you can swap any of the two, you can swap any of the two columns. First of all, try to debug that. You can swap any of the two columns, right? So if I try to swap this with this, if I try to swap this with this, okay, okay, if I try to this with this, so it will become 4 2, that is 1 5 9, and it is 3 8 7. Okay, great. If I try to solve this with this, that is 4 2 7, that is 3 8 7, and that is 1 5 4. Now you notice one thing. Yes, what is that thing? Your order is being maintained, which means if you're this row, if you're in this row, it will either go to this, if or it will either go to this. Okay, great. But one more thing is left. If you swap any of the two column, any of the two rows, if you swap any of the two rows also, so let me try to swap these two rows, that will become 4 5 8, and this will become 6 1 3, and this will become 2 4 7. Okay, okay, so let me now swap these two rows. Okay, I will tell you what I'm doing here. You will just get a hint like why I'm doing this step, and you will just solve it yourself only. That is 5 1 and 4. Now you notice one thing. What is the difference between this and this array? Oh, so this is the array which I have generated randomly. Okay, this is the array which I generated randomly, and this is the initial array. Okay, so you will notice in the randomly generated array, in your initial array, that if you try to make set of each and every column, if you try to make set of each and every column, so what is this column? That is, so what is this row? That is 1 5 9. Okay, great. So let me change the color. That is 1 5 9. I'm writing in increasing order. So that now what is this? This is 2 4 6. Okay, great. And what is this? This is 3 7 and 8. Okay, great. Now if you write this for the same, if you write this condition for the same, then what will your array? That is 2 6 4. This is the first, this is the second, that will be 3 7 and 8. Okay, great. Done. Now what is this? This is 1 4 and 5. Okay, so how is, I think so it is 9. I have somehow make it. Yes, this is 9. This would be 9. Okay, you can see this is 9 only. I'm not making it according to me. This is 9 only. Yes, this is 9. So this is 1 9. Oh, okay, okay, 1 5, and make it equal to 9. Okay, now you will notice one thing. Your set of both these numbers are same, which means 159 159 here, 159 here, 246 here, 246 here, 3788, 378 here. So you notice one thing, that after making any of this operation, after making any of this operation, either it will be row, either it will be column. If you construct a set of the rows of the columns, it would be same with your final representing B array. Okay, let me repeat again. If you make if you if you perform any of the operation, you can see I have performed row operation also, I have performed column operation also. So let me now make a and let me now swap these two rows also. So what will your row? That is 2 9, that is 7, and that is 6 1 and 3, that will be 4 5 and 8. Now you know one thing. What is your corresponding matrix for this? That will be 2 4 and 6. 2 4 6 here, 2 4 6 here, you can see 2 4 6 2 4 6. Now 1 4 5, 1 4 5 is here. Yes, okay. 1 9, let me 1 9 5 is here. This 1 9 5 is here, 1 9 5 is here. Now 7 3 8, 7 3 is 8 is here. Yes, 7 3 8 is here, and 7 3 8 is also here. Okay, now you notice one thing. Your set of your columns would be same at the end only, and similarly for the rows also. So what I'm trying to say with row also, like you can try to construct an array of rows. So now, okay, just for the rows, what is the set of rows in this, what is the set of rows in this matrix? The set of rows are 4, 5 and 8, and this is 6, 1 and 3, and this will be 2, 9 and 7. So let me get a set for this array also. Let me take what is the, this is the initial, yes, I will take this only. That is 1, 6 and 3, that is 5, 4 and 8, and that is 9, 2 and 7. Yes, so if 163 is there, you can see 163 is here, 163, 163, 548, 548, and 927, 927. So by swapping any of the rows and columns, your at the end, your set of rows and set of rows and set of columns in the sorted order would be same only. So that is the only condition which you have to check in problem array. So let me show the code. The code is also easy. What I'm doing here, just finding the, just taking the input and and putting the all the columns in the set, and checking whether all of your that columns are present in your final string B or not. If they are, if not, if any one of the string is not present, then answer is no, and you're done. And similarly check for the rows also. First of all, put all of your rows in your set and check if any of this row is not present in your final string, then answer is no, else answer is yes. So that's how you can solve the 5 problems of this problem set. So if you have any of the doubts in any of these 5 problems, you can please comment me down, and share this video for your with your fellow CP mates, and do subscribe to my channel, and please like, share, comment my video. Till then, stay tuned for the next one. Thank you.